we spoke about various operating systems that we have today, the client operating systems, the server operating systems, um, both Windows and non-Windows, including Mac operating systems. Then we got the various components of your motherboard and the hard drive that work together to accomplish a certain tasks. Then yesterday we spoke a little bit about networking, LAN, WAN, IP addresses, IPv4, IP, the number of bits that we have, subnet masking, the CIDR notation. All of this is very important for creating your cloud infrastructure, especially when we talk about VPCs. That's kind of a complex subject, but I'm going to make that easier for you. For that, I need you to understand the CIDR, IP addressing, subnet masking. Then we also spoke about what is a private address, a public address, static address, and a dynamic address. Then I gave you a task to work on the DHCP, how DHCP works. I'm sure you might have done it. Today we'll talk a little bit more on certain more topics or certain tools that will be helpful for troubleshooting the networks. So unless you have any questions on any one of those or any of those topics. Okay, silence is golden, yeah? Okay, thank you. Okay. Oh yeah, I forgot about registry also. A registry certain commands like msin 432, winver. I'm gonna share my screen. It's nothing out here, but still. I'm planning to put all the drawings here rather than doing it in MS Paint. I'll do the drawings here so that I can share those drawings with you for references purposes. Because I'm just losing their paints and maintaining those becomes difficult. Okay. Just a minute, please. Okay. Are you all ready? Sagar? I hope my audio is clear.
Yeah, it's
Okay,
good.
great. So today we'll talk about certain devices, the ins and outs of networking as to how different components work together. There are switches, there are routers, there are firewalls, there are hubs, there are so many of them that all work together to provide the basic connectivity. Yeah. Then we did speak about local area network and wide area network, but then there is something called as topologies as well. So we will also talk about network topologies, specifically bus, ring, star, tree, mesh, those things. Um, yeah, if time permits, we'll talk about certain tools as well that will help you troubleshoot as well. So one thing for maybe a quick question for everybody here in the audience, what is a loopback IP address?
127.0.0.1.
Perfect, perfect. Great. Seems like you've been doing certain research and homework. That's good. What is it used for? What is the purpose of 127001?
It is a loop back IP address and it is a default address.
Mm-hmm.
This is a ping command.
Right. So
It is used to it
uh-huh.
is used as a connectivities to check the to check between the connectivities.
Yeah, it is used to check the health of the network card if your network card is functioning properly or
Network
not.
error.
So,
Yes.
right. So you ping itself to figure out if it's working fine or not. That's great. Yeah. Good attempt. Thank you. So when it comes to networking, there are actually two essential pieces of equipment that enable numerous devices to be connected. So your laptops, devices, all of these are connected with two kinds of devices. One is a router or other is a switch. Switch are used in order to connect many devices on the same network. And these devices could be in the same building, could be an office or a school, and that can constitute of multiple devices like computers, printers, and different other gadgets. Switch is nothing but a controller that allows connected objects to share information with one another. Right? So when you have to connect two computers, you can connect it with a direct cable. The cable is called as a LAN cable, right? Have you heard of this LAN cable? LAN cable or the LAN port, LAN cable. LAN cable is also called as the Ethernet cable. The LAN port, there's a LAN port on your laptop, right? There's a LAN port on every laptop. That is also called as Ethernet port, or more technically called as RJ45 port. Okay. Now, in order to connect two computers, what you will need is, of course, two computers and a LAN cable. That's it. You connect each of them and give them an IP address, and they will be connected that ways. But what if you have multiple computers, right? What if you have multiple computers? So what you will do is buy a switch. You'll buy a switch just like the way you got a router at your home, the firewall that you have at your home. You can call that as a switch or even a hub. I'll tell you the difference between hub and a switch in some time. But this guy, there's a firewall here, right? And the rest of the devices like this, they will all connect to the router. I can do Control C, yeah. So all of these devices are connected, which are 1, 2, 3, 4, all of them connected to the router, isn't it? That's how you do it at your home as well. And hence, there is a two-way communication happening between the source and the destination, or we call it the source and the destination. So this box out here is a firewall, or you can also call it as a router. And on the right side are all your workstations. So router routes the traffic between multiple devices. So if there is a machine A wants to send information to machine D, it will go through the router. But what happens is when you want to send information to A from D, it will go to A only and not anywhere else. And that's the intelligence of the router. In place of a router, if you have a hub, right? If you have a hub, then let's say A is sending information to D, the packet will be broadcasted. The packet is broadcasted when we are using a hub. But in switch, it is not broadcasted. It is just sent to that information. So what does the packet constitute of? Packet constitutes of information like source, where I need to go, destination, the MAC address, timestamp. There's so many things inside the packet, right? Every packet is not more than 1500 bytes. Every packet cannot be more than 1500 bytes. So if you run a ping and run it to ping space www.google.com, it's going to give you replies. But how much of data is it sending? It is sending 32 bytes of information. As you see there, pinging www.google.com 172.217 whatever with 32 bytes. It's just sending 32 bytes. Like I said, a packet cannot have more than 1500 bytes of information. Ping is a utility that is used to check connectivity between source and destination. Source is my laptop in this case. Destination is google.com in this case. It could be anything. You type Facebook or something internal, or could be a laptop next to you. That is a switch. A switch functioning is to make sure that the devices share information between each other, and that is a point-to-point communication, not a broadcast. Hub will broadcast. That means every device in the network will receive the packet. If A is sending information to D, it is just broadcasted in the network. It will go to B. B will drop the packet because it's not destined for B. C will also drop the packet because it is not destined for C. And then D will ultimately receive it because it's there in the destination. Good so far? What is a switch? Switches are used to connect different devices in your network. Hubs are also used to do the same. But the difference is that switches do not broadcast, hubs broadcast. Good so far? Okay. Moving on, in addition to switches, what you also need is a router. They are very essential to connect different networks. So if you have a network and another network, let's say your home and your neighbor's home, you want to connect between all the devices. You got 10 devices at your home. Your neighbor's got another 6 devices, and you want to connect between them. You want to a great connectivity between them. Then what you will need is a router, right? So routers are used to connect different networks. So hence routers are usually the endpoints of the network. Endpoint is any device that is sitting at the end of the network is an endpoint. So you have your ISP provider. The ISP provider will have a router at the endpoint. You have a router at the endpoint. Look at the way they have connected. A cable is just coming in or plugged in through their router and your internet works. So it is connecting your network with the ISP's network, and that's how your internet is working. So these kind of devices like routers connect different networks to each other through internet, and that will allow data exchange between networks. But switch cannot be considered as a controller. A router should be considered more as a dispatcher, so it is just dispatching information from your network to another network. Are we good with this? Shravanti, there's another person who joined with the phone number 9201. Okay. Should I assume that you all understood this? I got acknowledgement from Sagar. Okay, it's good. One more. Okay, anyways. Okay, thank you. Thank you. Moving on, let's talk about LANs, WANs. I think we did speak a little bit yesterday, but I want to give a gist of it so you don't forget. LANs are used to connect devices across short distances. So anything that you got at your home is a LAN. So it could be within a building, within a school, within home, right? All of that comprises of a LAN. A wide area network is something that used to connect the devices over larger distances. The largest WAN in the world is internet itself. We are all connected using internet. So we are in that part of wide area network. So now that you know what routers are, wide area network can be established with routers so that it can connect different LANs, isn't it? So you got, let's say this is a building and then there's another building somewhere. Yeah, there's another building and there's another building somewhere here. So all of these can only be connected with routers, right? Each of these buildings will comprise of its own LAN. So this is a LAN, this is also a LAN, and this is also a LAN. But when you connect each of them, what they become? The connectivity between them is done only with the help of what? With the help of routers. So this building will have a router in the end. There's another building that will have a router in their endpoint. Yeah, here. That's a router. And there's going to be another router with this guy. And we will be connecting this router with this, and we'll have this router connectivity with this, and this router connectivity with this, right? So what we are essentially forming is a wide area network, isn't it? You can have a few more buildings connected if you like, but these are the two major ones. You may also see somewhere when you're searching on the internet something like a MAN, which is metropolitan area networks that will be covering larger areas than LAN. They are larger than LAN but smaller than WAN. It is typically covering just a city, that is a metropolitan area network, MAN, right? Okay, let's talk about network topologies. What are the various network topologies that we got? We'll pick up another paint here. Okay, so there are different network topologies that we're going to talk about. Number one is bus, then ring, star, tree. So that's about network topologies. Okay, so what's a bus? Bus. So the common backbone of a bus topology is a single cable that is connected to all devices on the network. So in bus network, let's say you got all these devices like this. So C, V, right? That's another device. That's another device. That's another device, right? All of these are your computers. Could be servers, could be desktops or whatever. But in LAN, in a bus topology, they're all connected with a single cable. And that cabling is done something like this that you see over here. The challenge is that it's a single point of failure.
It's
When
called serial connection, right?
serial connection, yeah, serial connection, good. That is as good as serial connection, and this is a bus topology. The problem is that if something breaks in between, there's going to be a disconnect between computers. Also, if machine A, let's call it machine A. If machine A wants to send information to machine the device which is at the last, oh, I have problem. Yeah, D. So if machine A wants to send information to E or data to E, then everybody's going to receive it. It's going to unnecessarily just increase the traffic. Okay, that's called as bus topology. Okay, I just want to save some space over there. Then moving forward, we got a ring topology. Ring topology. Then in ring topology, you will have devices similar to that. It's just that here, if machine A has to send information to E, it's gonna be going through B, C, D, everybody. But in ring topology, it will be in the form of a ring. So that's your device. That's your another device. That's your another device. We're gonna make two more. Hmm. Okay, and they will be connected in a circular fashion, right? They will be connected in a circular fashion, so you will have connectivity like this. This guy is connected to this. So again, there are advantages and disadvantages in each one of them. So if one of the first machine wants to send information to the last one, it has to go all over, circle again. That's a ring topology. So if I have to draw a mesh topology within that, a mesh topology will be something similar, but the connectivity will be between everybody and everybody. So this is ring, and if I have to pick up the whole thing, then this. Okay. Uh, okay. 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 So this will be mesh. The one that you see on the right hand side will become mesh if I draw like this. So here this machine talks to this guy. He also talks with this guy. He also talks with this guy. So every machine will be talking to every other machine. This is called mesh. Draw like this. Am I missing a point somewhere? A connection? So every machine talks to every other machine in this kind of network. Again, generating a lot of traffic, isn't it? Okay. Then that is your bus, that is ring, and then star. Star is like you got a hub in the middle, and rest of the devices are connected with your router for your devices. So the ones that we use at our home is the star topology, where you have the hub in the middle. Without hub, there will be no connectivity. If the connectivity breaks to the hub, we'll have no connectivity out there. So if I have to draw a picture to explain that better, um, so that is your center server, and you call it as, let's say, hub or a router, hub slash router slash switch, or can also be a computer. Then you will have the rest of these devices which are connected in a circular fashion, and that's how it is at your home as well, isn't it? You have all your devices that are connected to your router. If the router fails, everything is gonna fail. So you'll have a proper connectivity like this. So these devices could be your PDAs, laptops, desktops, mobile phones. A device could be anything. So such kind of a network is called as a star topology. It's found in all our homes, and the central connection. Also sometimes people call it as a hub, the center one. It's connected to all the objects in the network. Any questions so far? These are network topologies. Okay, thank you. Thank you so much for your feedback. It's important for me to understand whether I'm clear or not. Okay, right. So let's talk a little bit about cloud computing, because we have been talking enough basics. Let's pick up basics as and when we encounter them again. So we will start a little bit of cloud computing just to make the session a little bit excited, so that you won't get bored with the basics also. Um, have you heard of these jargons like SaaS, PaaS, and IaaS, software as a service, platform as a service, and infrastructure as a service? Right? So there is SaaS, there is PaaS, and IaaS. These are the three prominent ones. Of course, there are others as well, like um, communication as a service, um, applications as a service. There are a lot of other ones, database services, but these are the three prominent ones that will rule the cloud computing arena. And these are called as cloud computing models that NIST has developed. Let's talk about them one by one. So we'll write this heading as cloud computing basics. Okay. So what is cloud computing? We saw during the demo, I believe, but if you have certain information that is scalable and that's on the internet somewhere, your data is distributed everywhere in the cloud in various geographical locations, and you as an external customer are able to access it using any device, anywhere, at any time. That is cloud computing. If you are able to access your information that is located somewhere, distributed in some geographical location, using any kind of device at the time that you want, that is cloud computing. Also, you should be able to provision resources. So if you want a server or a machine, um, any kind of services like a database, you should be able to provision that anytime. That is on-demand service, right? Just like you want to book a cab or a Uber, right? So you should be able to get that anytime that you want. That's on demand. Different cloud models here: SaaS, PaaS, and IaaS. Let's see what they are. Now, SaaS is a business model in which you are actually saving a lot of software licenses, which involves development and support of the software vendor. And we as customers have an opportunity to pay just for what we have used, usually through internet. So the backbone of SaaS is internet, without which it's not going to work. Of course, the backbone of entire cloud computing is internet. An example of software as a service is Gmail, your Hotmail, Salesforce. All of these are software as a services, where you just have to type in your user ID and the password to log in, and that's it. You are responsible nowhere. You're responsible nowhere in the sense you do not have to take a backup of your emails. You're not provisioning um, electricity, power supply, air conditioning, HVAC systems, vacuum conditions. None of these is your responsibility for the Gmail servers. All you will have is a user ID and the password for you to log in, and that's it, isn't it? You will not have nothing more, nothing less. So you save a lot of money, so you do not have to maintain your own email servers. A lot of companies do. In corporates or in enterprises, the companies will be hosting their own email servers and do not give it to Gmail. So you will see that the organizations will have their own domain name. So the email addresses of the employees will be whatever, john@theircompany.com. So that is hosted in-house. But if that is outsourced to somebody called as a SaaS provider, you might have heard of Office 365. Oh yeah, Office 365 is also another example. Office 365, Gmail, Salesforce, where you are just using a user ID and a password to log in to your information. And your responsibility is just to log in, that's it. You do not back up, you do not take snapshots, no air conditioning, nothing. You just pay for what you have used. Shanti, you have a question. I see that in the chat you wrote you have a question. Okay. The question is, Dropbox and Cloud One come under SaaS. Okay, so wherever you're using a user ID and a password to access your information, that is software as a service. So I'm not sure what Cloud One does. What is Cloud One? Is it used to save information? Just looking online, is it Cloud One? Is it onecloud1.com? What do we do there? IoT? Okay. OneDrive. Okay. Okay. Yeah, Dropbox, OneDrive. Yes, there are software as a service solutions where you just use your data. You do not back up that data in the cloud, isn't it? So that's the Dropbox is also a good example. Okay, good. Thank you. Now, platform as a service is somebody who's developing a platform. It's for integrated platform for development, deployment, testing, support of web applications. So if you are a developer and you're looking to develop an application because you got a great idea, and what you need is a database, right? You need a database where you may want to store information. You may want to save a lot of information there. So for that you will need a database. A database is a platform for the application that you want to develop, and hence that will become the platform of your application. So wherever you are purchasing or whatever, leasing out platforms, specifically in terms of databases, then that is called as platform as a service. So platform as a service are used for applications. Mobile app is another example, which will help the developers create their entire framework in the cloud, like a database. So they don't have to purchase a database or manage operating systems on the database. You don't have to manage virtualization or storage or networking between them. Designers or developers just have to manage the applications. Right? So you as a developer do not have to focus on maintaining the server, but you can rather focus on developing the application and increasing your productivity and utilization rates. So that is platform as a service. Infrastructure as a service is everything that we talk about. Okay, the apps like, hey, no problem, you can ask questions, that's why we are here for. The apps like Amazon and Gmail also come under mobile apps, right? So are they SaaS? No. The apps like Amazon and Gmail, they are all SaaS, software as a service, and not PaaS, because you're not developing anything with Gmail, you're not developing anything with Amazon. You're just using them for, you just type in your user ID and password and access for mails. But any place where you manage your data and content and use a database in the background, and that database is in the cloud, is platform as a service. So they can get a platform, or they can get a framework in the cloud that will help develop their applications. Do you develop your applications with Gmail? Do you develop your applications with Amazon or Office 365? No. To develop an application, what we need is a database or a mobile app framework, or a Visual Studio. So any place where you want to develop the Visual Studio, the license of that is like thousands of dollars, right? So you don't want to purchase that license just because you want to develop an application. So what you're going to do is just lease that out or rent it out in the cloud. So Visual Studio is also another example of platform as a service. Right, so I'm gonna make some examples here. Anything that will act as a platform. What do you need to develop a mobile app like a Visual Studio? You also need PHP. You need a database, and the database could be anything. Could be relational database. Could be NoSQL. Could be MongoDB. Whatever, Postgres. Could be MySQL. Could be whatever. Yeah. Oracle, all of these things. So that's a platform for your application. It's a framework for your application. Okay. Now, infrastructure as a service is anything that you need to build your data center. It could be routers, servers, storage, networking components like firewalls, right? If you want to build all of that in your data center, private or public, that is called as infrastructure as a service. So they are self-service models mostly, which will help you monitor and manage your remote data infrastructures. So let's say 10 years ago, 15 years ago, people used to set up their own data centers. At that time, they have to purchase their hardware outright. They have to invest good amount of money into spending, what we call it as CAPEX. Right? There are two components of it, CAPEX and OPEX. CAPEX is capital expenditure, where that goes as your initial investment of the building of your car, of your house, whatever you have used for initial expenditure is CAPEX. Whatever you're using later on is OPEX, where that comes as operational expenditure. So operational expenditure is something like electricity bill, maintenance, employee salaries, air conditioning bills, utilities, everything that comes as OPEX. So infrastructure as a service, organizations used to purchase all those equipments outright, and they have to put a lot of budget in there. So startup companies will have a hard time purchasing such heavy equipments outright, and hence for them it will be best deal for them to go to cloud-based solutions where they can pay for those services, pay for the firewalls, pay for the storage, pay for virtual computing, pay for networking as their business progresses. Right? It is also, hence cloud computing is also called as utility computing. Okay? Okay. But in infrastructure as a service, you're responsible for a lot many things. You're responsible for managing your applications on the server because you built it. You're also responsible for the data that is there on the application because you host it. You're responsible for the operating systems. But the provider, the vendor, will manage the virtualization, manage the servers, manage the hard drives, manage the storage and networking. So the responsibilities vary. If you are using SaaS, you have no responsibility. If you're using PaaS, a little bit of responsibility comes into picture. If you're using infrastructure as a service, you have more responsibility as compared to other cloud models. Any questions around SaaS, PaaS and IaaS? Okay, great. There are some more concepts here, which we call it as private, public, and hybrid. That is also something we need to understand. Let's talk about that. So we'll talk about private, comma, public, and hybrid. Okay. The network that you have at your home with your Wi-Fi router and several devices connected is a private network. That is something owned by you. So a private network is owned by individuals, owned by organizations, and owned by enterprises. That's a private network. So when you have a local LAN, right? When you have a local LAN in the enterprises or in offices, that is a private network. A public network is where you provision resources in the cloud. Let's say you have created your entire data center in the cloud. That is an entire public network. Where is your Gmail? It's in the public network. Where is your Hotmail account or Yahoo account? SkyDrive, all of that is in the public. Those are examples of SaaS. But if the organization decides to keep their infrastructure like servers, router switches with Amazon or Azure, it's called as a public cloud. And hybrid cloud is a combination of private and public, where a part of your network is in the private network, another part of the network is in the public. An example of that could be a traditional, let's see, an example of that could be a front end and a back end scenario where new drawing. Okay. So an example of that is a front end and a back end network. Let's say that is your LAN. Okay. And what you're doing is let me create another one. Let's say that is in your cloud. Okay. And also make it here. This is LAN, and that is also called as a private network, and this one is public cloud. LAN slash, let me show that and say private. Okay. So let's say private cloud, and on the right side you got public cloud. In your private cloud, what you have is, let's say, a web server. Let's say that's your web server. Yeah, that is your web server. So we'll talk about different scenarios when and where you will have a hybrid network. This is the first scenario where you have a private network inside which you have a web server. A web server will typically also have a backend server, right? Like your HTML pages that will connect to your databases, right? So let's say go ahead and create another server, and that's in your network here. So this is a front end server, and this is backend slash DB database. So okay, web server. Good. And you want to create a network like this. You want to keep the backend database server in the cloud. Why? Because you somehow think that your um, your environment is not secure, and you want to create the backend database server in the cloud. So that ways, when the consumer hits your internet, so let's say there's a call coming from the internet. That's a representation of the cloud, and that's the best picture I could get from this drawings. Um, arrows like this. So, yeah. So when a consumer tries to connect, he's going to first hit the web server. You're going to Gmail, you're going to Yahoo or Facebook, wherever, whichever website you're going, you're first hitting the front end server, isn't it? Front end, which is the web server. And then when you try to query information like filtering data, removing or going to deleted box, then the front end web server queries on behalf of you, right? That is a query which will be queried on behalf of you. Typically, the backend server, you can keep it in your own private cloud as well. But for whatever situation, you might have kept it in the public cloud. So this is an example of hybrid, where a part of your infrastructure is in your private cloud in your premise, and another part of it is in the public. That is one case study. Understood? What is hybrid cloud? Yeah, Sagar?
Yeah, I'm good, Anand. Yeah.
Okay. Shravanti? Okay. Do you understand private and public separately?
Yeah, I understood both, but I didn't understand what's hybrid.
Hybrid is where a part of your network, part of your infrastructure is in private, and another part of it is in public. So using both of them, right? So at your home, you decide to build a website at your home, and you start building it. And in the middle, you decide that you need a database as well, but you cannot purchase a database, right? It's difficult. I'm not saying that it's about your potential. It's about the cost that will come with it. So if you have to set up a database server in your private cloud, right, in your home, at your home, then you have to purchase the server, you have to get the licenses for the operating system, get the licenses for the database, and that's going to be a lot more expensive. You also have to maintain it. Electricity and other OPEX cost will come with it. So what you decide is, let me go ahead and purchase the database with some public provider. So you contact Amazon and create a database over there instead of creating it at your home. And then in your HTML code or in your web server, you will write or modify code inside.
Oh, okay, I got you.
Right. So a part of your infrastructure is there in the cloud, and another part of it is there in your private cloud. That ways you are utilizing your front-end server, which is, I mean, front-end server really does not need so much of maintenance. It is just plain simple HTML, JavaScript and CSS files, which can be kept even on your laptop. But in the back end, if it needs a powerful database, with couple of terabytes of hard disks and some 200 GB of RAM, then that's going to be difficult to procure at home. So you try to get that.
Like, can I think this is like creating a blog or a YouTube channel, the hybrid cloud examples?
No, because you do not have anything at your home. Everything is in public in that case. A blog, do you have the front end at your home? HTML pages, do you have the blog server or the YouTube server at your home?
No, okay. Can you give me any example for hybrid cloud?
I will give you another example. This is one of the case study. Another case study is something that I will give you pretty soon. So this is one kind of it. So let's say I'm going to explain that again. Let's say you want to create a website and you open Notepad and start writing the HTML and CSS code over here, and also incorporate a couple of Java code, and all of a sudden you realize that you need a database connection. You need a database connectivity, right? So what you gonna do there? You cannot purchase it. You have to go and ask somebody, which is a cloud provider, and then connect this HTML piece of code with the database that is there in the cloud. So a part of your infrastructure, which is your web server, is at your home / office, right? The rest of it, which is the database, is there in the cloud. So you are essentially creating a connectivity between your web server that is at your home with the database server that is in the cloud. Hybrid.
Okay, I got you. I got you. I understood.
So when the customers access your website, they will be eventually connecting through your ISP and to your home internet, not literally, but they will be coming to your home web server, and the web server, when needed, will redirect the traffic to the database server. I would like you to research something on how does front end and back end servers work. Just research on that. Okay, what is a front end and a back end server? Is it clear now?
Yeah, yes.
Can I know the name of the person who joined with the phone number? I know
Sir,
Sagar.
it's not phone number, it's ID.
ID, okay. Okay, that looks like
Shilpa sir.
Shilpa, okay, hi. Hi. So am I clear? Is it all good so far?
Yes, sir.
Okay, that's so I'm going to give you another case study here in a scenario where you will be using a public cloud. Okay, let's say you got even the backend server over here. Yeah, let's say you got a very small backend server, and I'm going to copy this. I'm not able to copy. Am I? No. Okay. So rather than doing the hard work, I'll do the smart work. I'll just create another one. Okay. 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 Let's say you got your own private infrastructure. Forget about public cloud at this moment. Okay. And you decide not to go with the public cloud because one of your friend gave you a server and said that, hey, don't waste your money there. I already have a server. Take this. All right. And that server has a very basic configuration. Let's say 4 GB of RAM and a i5 processor and maybe 512 GB or 1 terabyte of hard drive. That's fine. And you are so happy that you do not have to ask any cloud provider or anything. You do not have to spend any money out there, right? So there is no connectivity between your private cloud and public cloud. So everything is going between your front end server, which is there on your premise, and whenever customer comes in and does a query, it gets connected to your backend server, which is also at your home or in your office. Good? Is this scenario good so far? So I essentially do not have anything in the public cloud. Okay. Now, let's say you are hosting an e-commerce website where you want to sell your own small little product that you are making at home, right? With the help of few more people, you're making that at home, and the front end server, the customers are hitting the front end web server, and I just got a pop-up that there is an audio quality issue. Can you hear me? Hello, can you hear me?
Yes, sir.
Okay, okay. Please unmute. Please take the effort to unmute yourself. I speak for hours, so I need a lot of energy. All I need from you is a yes or no on the mic, so that will be really motivating for me. Thank you. Okay. Um, so there's a front end and a web server, and you're developing some kind of a product that will be helpful for the people, a small little product, and you have your own front end web server and a database backend server at your home. So there is no dependency on the public cloud, right? What you decide to do, after a successful business, couple of months, you plan to do a Cyber Monday sale or a Black Friday sale or whatever. You try to do that. And what's going to happen at that time? All your customers are so happy with your product and they have given references to every other person. And let's say a lot of people are waiting for a sale on your website because your maybe product is not within their reach or uh, not so cheap. It's expensive. Let's say it's $1,000 product or $500 product. Not everybody can buy that. So they're waiting for a sale. And on that sale, you give 40% off. Okay. So wow, this amazing product is coming at a 40% off, and all the people across all the 50 states will hit your front-end web server, correct? And there's going to be enormous traffic flowing in and out of your front-end web server and through your ISP as well. And there will be a lot of traffic going on and off between the front-end server and the back-end server as well. What's going to happen? It will be just not able to take that amount of load. So either your front-end web server will crash or your back-end web server will crash, or maybe both. We don't know. Anything can crash because it's not able to take up that load. They are just very small machines, like 4 GB RAM and little bit of amount of CPU. They can only take so much. They cannot take everything. A traffic coming from all states, at least 50% of the traffic hitting your web server, the processing will be very slow and the customers will be dissatisfied. Correct? You understood the scenario so far?
Yes, sir.
Okay. Now, what's going to happen is you're going to start losing business and you go and start discuss the same thing with another person, another friend of yours who may be a cloud expert. And he says that, okay, you go and talk with him and this is what happened. You were doing great business and on a Cyber Monday, everything failed because my web servers and backend crashed and I'm not sure why, right? That's what you're going to say. So that's only because your web servers and the web server and the database server are not able to take so much of load and traffic. That's a good situation that you are in. So you have two options. Number one is to purchase new web servers with high configuration and deploy all of that code onto the new web server and the new database server. So you have to purchase a couple of machines, which again is a capex, which you don't want to do because you have cloud, right? What can be done is that when the resources in the computer or in the server are about to reach 70% of their optimum utilization, you can provision a new server in the cloud, right? When the resources are about to reach 70% of their utilization, you can provision a new server in the cloud which will be the exact replica of these servers, and the traffic can then be redirected to the public servers. And that will only happen during the Cyber Monday, but after that, rest of the days, Tuesday, Wednesday, Thursday is no traffic at all. At that time, your in-house on-premise servers will be catering to the traffic. So that ways you only pay for that duration of the time for which your servers were provisioned in the public cloud. That is another example of hybrid cloud. Got it?
Yes, sir.
70? Sagar?
Yes.
Okay, Sagar.
Yes, Anand.
Okay,
Yeah,
this
I replied.
okay, this entire thing is called as rapid elasticity. So it means that the cloud infrastructure is flexible enough to move from your on-premise infrastructure to the cloud, and they are elastic. And rapid elasticity is not only from private to public, but for a customer who has chosen and embraced public cloud only. He does not have any private cloud. He has only public cloud, right? At that time, his front end and back end servers are there in the public cloud. And when the traffic is hitting and it reaches the 70% or 60% of the resource utilization, there will be automatic spawning of new virtual machines. So you can automatically spin up machines or instances or databases based on the network traffic and resource utilization. That is called as rapid elasticity. This part, moving from private to public, where you burst out your traffic into the public, into the cloud, is called as cloud bursting. So you need to understand the terminologies. What is cloud bursting? Another one is what? Elasticity or rapid elasticity. Okay. Any questions around this?
No, sir.
Okay. Shanti, any questions?
No, I guess no.
Okay. Give it a read. What is cloud bursting? What is rapid elasticity? Also, since you're reading that, you may also encounter another word called as scaling, right? What is cloud scaling? So give that a read as well. And I'm gonna save all of this. I still have to send those videos, upload that. Yesterday I tried to upload, but there was a bandwidth issue, so I'm gonna try that again today. Put that somewhere in the cloud and share it with you. Unless you have any questions, we're gonna wrap up for the day, and that's your homework. Give it a shot. Learn about cloud bursting, learn about rapid elasticity and scaling. And if you got additional time, I would also like you to invest some time on understanding virtualization. What is DNS? What is DHCP? And also download a software called as what? Virtual Box or VMware Workstation, because tomorrow will be a virtualization class.
Uh, Before this, you gave one more homework, right? To research on something. I didn't make a note of it. Can you repeat it again?
When today?
Yeah.
That was about networks. Maybe it was about what is what is MAN? What is MAN? Metropolitan Area Network. I hope you're making a note of all of this and you have a pen and paper handy. You're making notes there, isn't it? Are you? Everybody?
Yes, sir.
You are? Okay. So that's your homework. Understand about virtualization. All of these. What is a front end and a back end
And
server?
then backend
Right,
server.
right. So yeah, what is a front end and a back end server? And this you don't have to spend the whole day, but just couple of hours will be worth it. So read about front end and back end servers. Of course, you are refresher about all of these SaaS, PaaS, IaaS. What is public, private, hybrid? Also learn about front end and back end servers. Do some work on um, cloud bursting. Yeah, things like that. Okay. All right then, let's call off for the day. Unless you have any questions, we'll wait for a minute and close the call. Thanks, Sagar. Thanks, Shamanti. Uh, I forgot the last name.
Thank you.
Thank you. Thank you.
Shiva sir.
Yeah. Thank you. Bye bye.
Thank you. Good night.
Good night.